My name is Harald. I'm one of the founders and the CEO of Visometry. We are a spin-off from the Fraunhofer IGD in Darmstadt, the Institute for Computer Graphics, where we did applied research for the last 20 years. So we spent lots of time in creating a computer vision-based tracking system, starting with markers and other functionalities, and especially also a model-based target tracking system, which now is also in wide use with our SDK and our applications. During this time at the Fraunhofer, we also saw lots of companies shine and fail, and we also did lots of customer feedback sessions and user studies where we also collected lots of experience of customers, how they use applications. And there we collected lots of insights and knowledge about which augmented reality use cases work and which are more getting stuck. And so this talk is about all these insights about the augmented reality applications which work, or what kind of ingredients are needed to make an augmented reality applications really valuable and also usable on the shop floor. So regarding the industrial application landscape, there are lots of different kinds of applications. Typically the IKEA Place app is a well-known consumer application, but there's also lots of connection into industrial space, because placing furniture can be one thing in your home, but of course you can also place machines or other stuff in the factory floor and check if there are any conflicts or if these machines are at the correct place. So there are more lightweight use cases for marketing purposes, in showrooms. So this with the exterior car is one application we created, also for a showroom, which is a nice fancy eye candy stuff, but at the end it's not so sustainable at the end, because people look at it and think, oh yeah, this is very nice, but it's not something which is then used on a everyday scale. And then there are these maintenance and repair scenarios. They of course provide more value because they can be used on a everyday basis and guide people how to use certain, how to process a maintenance task, or providing step-by-step instructions to guide some worker to a goal, what he needs to be getting done or built. So here some other applications, training is an interesting use case to enable people to get them to know how to use, how to maintain a certain machine, or how to use this. So here, this on the left side is a short manual we created for a water analyzing machine, and people can just swipe through this app and quickly understand how they use this device. Or the maintenance and repair overhaul is a augmented reality evergreen. This is a very interesting use case, but the big problem is always you need to create lots of content, and this content creation is of course something which needs some effort to do, and so this makes this maintenance and repair case also kind of difficult, because there's this big content thing. So what needs to be done? So what are the ingredients for a proper and useful augmented reality application? So the first thing is of course the application, the app logic and the user interaction on the top level, and then on the technology stack, the tracking engine, which is necessary to place the 3D content in such a way that it seems anchored in the real world. And so of course rendering is also a component. But these days many people use Unity as a game engine, so this could be this is one of the most common components. And then of course you need content, especially for these maintenance and repair scenarios. They are very content heavy. So there are also other scenarios which are not so content heavy, but at the end you always need the content somehow getting into the application. And yeah, this is like one big issue which you need to overcome to get like an application scaled, and not only create like a nice proof of concept which can be shown and demonstrate the purpose, but really roll out an application on a wider basis and scale the application like in a company-wide manner. So like here's an example of one of our partners from Scope AR, like coming from a manual with lots of instructions, and which is like quite complicated to look at and needs like lots of effort to write and also to read. Like an application where you just take the 3D instructions into the AR space, of course, is a value which helps to carry out these maintenance tasks like much quicker, and people who are not so skilled are able to apply any kind of maintenance in a way which could not be possible by just reading paper manuals, which are like maybe just too complicated to understand. This is like also a time-consuming transfer, like the process of reading the manual and applying this what you see on the physical space. So this, of course, is like a big benefit of augmented reality, than having this value that the connection between some information is made like quite short and direct into the camera image, and the guy who performs out a maintenance task is like then well equipped and can do like this instructions way quicker. So here are some typical use cases. Like one is also from our partner Scope AR, who are having this, like they are also using like our technology underlying for the model target tracking, but they have this content system and create like content for like certain step-by-step instructions. And with this platform, is of course way easier to create content in a faster way, where you can also reuse stuff and then create like these content pipeline way faster. Or like 3D, they are using the Instant 3D Hub is like an infrastructure where lots of 3D data can be streamed into an application and can handle huge amounts of data. Or also TeamViewer, who are using this as a step-by-step instruction for maintenance tasks. So one thing is that this is like nice and it provides value, but for many of these maintenance tasks, it's also a bigger some problem that there's no validation. So you perform out these tasks, and if you have done something and then you go to the next step, like if you only use this for visualization, then it's kind of unclear if everything has been done correctly. So that's like one of the biggest missing points, that there's like no validation between the task which have been carried out and the validation which should check that there's something correct or incorrect. Yeah, and this is some gap in many of these maintenance application tasks, that it's nice to have like these instructions, but at the end there's like something missing, because it's hard to validate this. And so this is something which we also experience to be very valuable at the end, that people not only get these instructions, but also get some feedback of their work if stuff has been assembled correctly. So one possible solution is, during these steps, that we use the computer vision system not only for tracking, so for estimating the camera position, for applying like the 3D data like on the correct place, but using the camera, which is always on for the most devices, also for analyzing the scene and checking if the scene provides the information if stuff has been assembled correctly or not correctly. And of course, from a hardware side, it's all there. We have like the camera, and there are lots of computer vision algorithms or pattern recognition methods which can be used and applied to gain more information of the actual situation. And so when we look at the ingredients of an interesting augmented reality applications, we kind of extend the whole tracking block also with a validation block. So that, as I mentioned, the camera is not only used for estimating the camera pose, but also being used for validating certain tasks or certain steps during any kind of assembly process or like inspection process. So here, this is an example of our core system. So like when we spun out from Fraunhofer IGD, this was like our first product, like the VisionLab SDK, which is like a model target tracking. There we take any 3D model as a reference, and because we only rely on the geometry, it is very robust also for like metal shapes, like reflecting surfaces or like lighting conditions, changing lighting conditions. And so this is like the core system using this model target tracking as a functionality. In contrast to like this visual inertial SLAM methods, which is used in the IKEA Place app, or like what ARKit is currently providing, the model target tracking is able to provide like the 3D content in a certain context. So to anchor this in a very defined position of some existing part or some existing scenario, and this can be done like in a millimeter accuracy. And so this makes it possible to precisely place like furnitures not anywhere in the room, but place like the 3D content like with a millimeter accuracy on top of a certain reference. So the first step we did was using, like regarding validation, was taking this model target tracking and not tracking only one model, but tracking certain components of the model. So having a core body as a tracking reference, and then any like certain sub components of the model. So here we have like the car as a core body, and the car door as a separate component. And we both use the model target tracking for both parts, and therefore we are able to check the door, if the door is open or if the door is closed. Or like is another example where we not only check for existence, but where we can also check, because we are tracking both models, we can analyze them and check them if they're in a certain tolerance range. So for assembly instructions, it's then it's possible to check if these parts are in a certain tolerance range within the whole assembly structure. So there are different ways of applying this validation in augmented reality. So the first one, which we just saw, is like taking the 3D geometry itself as a reference and analyze this within the application, which can be then used to check for existence of certain components, but also for the placement of certain components if they are placed in a certain tolerance range. Another thing is also to use the 3D geometry not like component-wise, but like globally, and validate like on a pixel level if these components are matching in the camera image. Or there are also more sophisticated AI-based methods where it's possible to check certain features in a structure if they're existing or if they're correctly placed. So here are a couple of examples. For the first part, we have like this multi-model tracking where we have like this body, and we are able to check if certain components are correctly placed or if they are like assembled in a wrong position. And this is like fairly easy for larger parts which have like distinct geometry and which can be properly detected in a camera image. And so here, for example, another scenario of a specialized vehicle, and here are some also structures within the body which can be checked by taking these components as a 3D model and using those to check for existence and also for correct alignment. This works quite well when there are like larger structures, but when you use the geometry, it's kind of you kind of depend on like a good reference, and if like parts are like too small, or like smaller screws or smaller bolts or very simple plates, then the geometry-based referencing is just not stable, and this makes it not so usable. So the less complicated the structure are, the more complicated it gets, and so therefore there are the limitations using these model-based validations. And so the second thing we had was like the direct validation based on the geometry. And so here we have a structure where we take the shape, or like extract the shape of the whole 3D model and use the contours and shapes, compare this in the camera image if there are also edges in the camera image at the same spot, and then do like a color coding. So like when stuff is matching, we use like a green color coding, and if stuff is not matching so good, we take like other colors, or like if states are like undefined, we color them differently. And here we see a couple of examples where you see like the reddish shapes, which is like an assisting function then for the quality engineers to get some hints where to look more intensely and to check what's wrong. For example, these holes, drilling holes, which you see here, they are then automatically detected indicated with the red color that there's like not a match between the virtual model and the physical model. But this is only like a low-level feature, so it's only giving you some hints and telling you, look at the red spots, but it's not really giving you distinct answers which parts are like correct or not correct. And so other option is using AI-based methods. Here we have an example of lots of bolts which need to be checked, and of course when they're like big chassis, sometimes they're like thousands of welding spots or bolts, and of course it's like no fun if you go through all of them manually by clicking that they're okay or not okay. And so here it's like very interesting having like an AI-based method automatically detecting these bolts or welding spots in a way that they just need to be in the camera for like a minute, for like a second or two, and then you have like a result if this welding spot is correctly placed or not. All right, based on this technology, we created like a tool named Twin, like in relation to digital twin for addressing like quality engineers who are in the need comparing virtual 3D data with the physical parts which are assembled, and also documenting these differences. So therefore we have like a documented workflow, like a digital workflow to document like the differences between the physical parts and like the virtual data. And there are a couple of customers who use this application for more like for larger welding structures, like lots of metal processing, and this application is then very valuable because it can be used like every day. Because like in relation to like maintenance applications, they can be kind of when people carry out this maintenance like a couple of times, then they know how to do it, and then they don't use this application anymore. But like in the area of quality inspection is very valuable because they can use this application every day, because all the parts which are produced, they are always different and need to be checked. So it's like like a use case which is like very valuable. Here's an example where we also use this for the detection of welding seams, which is also one option to check the existence of certain parts. So this is like a booster in many use cases of using augmented reality, and it helps the quality engineer to quickly understand what's different and what are the problems in this certain validation step. And at the end, we have like a documentation, so a fully documented process, a digital process from like the beginning. Like typically, people use like paper sheets and like measure sticks to check certain things, but having like this all contained in an iPad app really shortens the process and makes it very interesting, like for quality engineers. And so also here, one of the biggest benefits was also not only visualizing the certain information onto the screen and let the quality engineer decide by himself, but also using the computer vision and the camera system to analyze the scene and assisting the user in his tasks and what he's doing with the application, the AR application. So before we close up, here some brief infos about like our spin-off, which we created like 8 years now. Like we are out on the market for 8 years. Our first product was the VisionLib SDK, where we address like quality and augmented reality developers. And then we created the Twin application, where we address like quality engineers. And the Twin application we have now on the market for like about 4 years, and have like a couple of hundred customers who use this on a daily basis. So yes, this is just some infos about the VisionLib SDK. So it's like a very, very commonly used tool now for model target tracking. The benefits are that you only need to take the 3D model as a polygonal mesh. You don't need any pre-processing, no preparation, but you can directly work on the polygonal mesh model and use this as a tracking reference. So it can also be used by taking the Unity, like the game object geometry from the geometry out of a Unity game object and directly push it into the tracking system during the runtime. So there's no pre-processing or preparation in advance, so it can all be done during the runtime. So like another dilemma is about like all these classes. Like we also have, like in the last 20 years, we have seen lots of companies creating classes, and many of them have already disappeared, and new classes are coming out there. And we also spend lots of time in deploying our tracking technology to all of these, to many of these classes. And we also carried out lots of user tests for applications which have been created on the glasses, but also on tablets. And for many use cases, our experience was that the glasses are really nice to making cool showcases. And when the HoloLens came out, like everybody was really excited, and because like it was a very innovative device these days, but it was very hard to create really applications and scale them out on the shop floor because the ergonomic aspects and the usability are just like not in such a way that people want to wear them like for the whole day. And for many user tests, we got the experience that people are very more comfortable with tablets, and that's also why we mostly focus on tablets these days. Because I know the hands-free argument is of course there, but it's also okay if you go through some instructions and get like the infos. It's still like more value than just reading the paper manuals, and you get like more insights more quickly. But it's still often way easier for people to use than the typical glasses, which are often more hindersome. So our advice to many of these customers who come What about glasses? We often tell them, better think of iPads, because iPads are really the most interesting devices these days to use for industrial use. And of course, we also look at new glasses, but yeah, we know this is always a big problem. Oh, sorry, yeah. All right, so yeah, like takeaways. When you design any industrial application, don't only look for the visualization, but also look for the validation of the tasks, or like the steps which we are doing, because they are a quite big amount of the value which can be provided in this application. And of course, yeah, don't wait for the glasses, but just be ready when they come, and do the tests and tries and proof of concept also on the tablet. It's not such a big thing to switch to glasses when the value of the use case is proven. All right, then I think I'm through. Thank you very much for listening. You're welcome to ask any questions. You're also welcome to come to our booth at the expo, and there we can of course also answer you any other questions. Thank you very much.
Actually, I have one question. So on the HoloLens, are you saying that, did you feel it was a capable platform and just too expensive, or on the technical side it didn't live up to the needs?
Yeah, like from the technical side, it's more like also the battery life, but also from the ergonomic side, that people are just not that comfortable wearing these headsets like on a longer basis, and also make them uncomfortable if they are completely like for the VR glasses, for the see-through VR glasses, it's more like we're getting more uncomfortable because they're kind of shut up from the real reality, which is fine for like certain experiences, but when you just do the daily business and yeah, have a chat with some colleagues here and there, and then it's always a bit like a hinder.
Any questions?
It's not so much a technical question. It's more of a provocation, if you allow me.
Yeah.
So I don't know if you read the book Mana from Marshall Brain. It's a book that's maybe 20 years old, and he was describing this future that was quite sci-fi at the time, which was that humans were basically going to just be bodies for AI systems or computational systems. They're going to be acting out instructions, and these instructions, if they're not carried out correctly, will be corrected. And in computer science, we're also all panicking because a lot of software engineers are fearful they're going to be replaced. I'm okay with being replaced, but what these systems kind of project is not so much replacement, that we might be sort of, again, acting as just flesh to computational systems. And this is more of, I guess, a philosophical positioning. I don't know if that sort of that dilemma ever entered sort of any discussion at the company of how we. I worked at Siemens in the past, and we worked with the Google Glass, and we didn't have validation, of course. The validation was the system asking the user, this is how it should look. Is it like that? And that required some input from the user, and the user felt as a collaborator. I wonder, of course, you're going to get a lot more precision and I guess satisfaction from the user. Mental demand goes down, cognitive load goes down. But I wonder from I guess more a philosophical perspective, that the human is carrying out instructions from, it could be an AI agent, could be a team of AI agents, the manager is an AI and the sub-manager is an AI, and then the worker is human flesh carrying out these instructions.
Yeah, well, of course, like when I look at the quality inspection case, of course, there the augmented reality application on an iPad, it's still designed for human person to look at the tablet and make some decisions based on what he sees. Of course, this can go towards like a fully automated system, that there's just like a camera looking at something and detecting everything automatically, which is also okay, which also happens like on mass production things where there are only cameras and doing like all the inspection stuff without any human person validating this. But like for smaller parts, it is still interesting. And so as long as people using this tablet, it's still like the quality engineers who makes the last decision, and these are like all only assisting functions for the quality engineer to help him making these decisions. And to that point, it's still like the human person who is like in charge, making the final decision. But if the systems are good enough and making better decisions than human people, then of course the human person is replaced by like any AI system, and there's only like a camera doing the job.
So, Augusto, are you okay being replaced as a computer scientist or as a professor, or both?
More of a sort of software engineer practitioner or programmer.
So we're going to take a brief 2-minute break and cue up the last presentation.